In the world of sports, where the stakes are high and there is much more to gain than winning an Olympic medal, athletes have succumbed under pressure and resorted to unconventional methods in order to achieve success. We've already witnessed the recent downfall of Lance Armstrong and the conspiracy with the Sochi Olympics. With the 2020 Olympics around the corner, it is time for us to gain awareness of the newest frontier in doping in competitive sports, gene doping. The central thesis of my paper is that the ban on gene doping under the World Anti-Doping Code is ineffective and is in need of reform. To put all of this in context, I will first provide some background into what gene doping is, introduce the ideal candidates for gene doping, and identify some of the risks involved. So, what is gene doping? Put simply, gene doping involves the transfer of genetic material into the body for non-therapeutic purposes, such as enhancing an athlete's physical performance. Specifically, the genetic material is encapsulated into a virus and transferred into the target cell. Gene doping was developed from gene therapy, which unfolded when scientists first began looking for other ways to treat genetically based illnesses and diseases. There are two forms of gene doping. The first one is the somatic cell modification, whereby the genes in a bodily cell, such as a muscle or a lung, are modified. And the second is germline modification, which is where the germline of embryonic stem cells are modified. And my paper focuses mostly on the former, which is somatic cell modification on athletes. There are several candidates available for gene doping, but for the purposes of this presentation, I will be referring to the three primary candidates and refer to them throughout. The first is erythropoietin, which is EPO for short. It's a hormone that's produced by the kidney that increases the hematocrit levels in the body. By inserting an extra copy of the EPO gene, you increase the red blood cell count and therefore elevate your capacity to absorb and carry oxygen. So it's ideal for endurance athletes such as cyclists or marathon runners. The second is Insulin-Like growth factor, which is otherwise known as IGF-1 for short, which is a protein that stimulates both the muscle growth and differentiation tissue, and overall growth of the bone tissue. By inserting multiple copies of IGF-1 into a specific muscle, it can not only increase the muscle mass, but also help muscles repair themselves. This is also ideal for any athlete of any sport who wants to target a particular muscle group. The final one is myostatin, which is a negative regulator of muscle growth and differentiation. So by blocking myostatin, you can similarly result and achieve an increase in muscle mass and muscle hypertrophy. Scientists have already witnessed favorable results in animal trials. For example, the introduction of IGF-1 into the muscle of adult rats produced marathon rats, which saw a 15% increase in their muscle size and strength. When the myostatin gene was introduced into the muscle tissue of adult rats and it was made non-operational, this similarly resulted in a 25% increase in muscle mass. There's also suspicion that this might already be occurring amongst athletes. Notably, at the 2006 Winter Olympics, Thomas Springsteen, a German running coach, was convicted of doping charges and given a suspended 16-month jail sentence for giving performance-enhancing drugs to teenagers. In particular, emails sent by Springsteen made references to ripoxygen, which is a banned substance that was to be used for gene therapy trials for patients who were seeking treatment for anemia. Curiously, ripoxygen is also effective for inducing the release of EPO. The risks of gene doping have also been prevalent. The overexpression of EPO can lead to an unexpected elevation in hematocrit levels and result in the excess thickening of blood, strokes, and heart failures. In fact, the insertion of the human EPO gene into mice halved their lifespan, damaged their kidneys, and also their nerves and muscles. Such risks have also been materialized in humans. In the late 1990s, out of 11 boys who were treated and received gene therapy to repair their immune systems by replacing missing proteins, 3 of them contracted leukemia and 1 died. More recently, a 3-year-old boy in 2007 who was also treated for gene therapy also contracted leukemia and died. So this brings us to the World Anti-Doping Code. In 2003, the World Anti-Doping Code added gene doping on its list of prohibited methods and defined it as the non-therapeutic use of genes, genetic elements, and or cells that have the capacity to enhance athletic performance. This definition has since been expanded to include the use of polymers of nucleic acids, gene editing agents, and normal or genetically modified cells. The relevant provisions under the code are Articles 2.1 and 2.2, which prohibit the presence of any prohibited substance or the use or attempted use of a prohibited substance or method. In particular, liability under these two provisions is strict, and therefore the intention, fault, or negligence of the athlete or doper in question is irrelevant. Article 10 prescribes the sanctions which may be imposed on athletes if they're found to have committed an anti-doping violation. If the violation takes place during the event, then the athlete's results may be disqualified under Article 10.1. If the violation takes place after the event, and it involves a specified substance, which is a category that all doping agents fall under, then athletes face a base sanction of 2 years, unless the agency establishes that the violation was intentional, in which case the athletes may be ineligible for 4 years. My main argument is that the code doesn't adequately cater for the reality of gene doping, which may or may not already exist in sporting competitions. The first issue is the permanency of the effects of gene doping. Once alterations are made to the human genome, this becomes part of the cell's own genetic material and changes an athlete's genetic code forever. It is unclear how this operates in light of Article 10 and the sanctions that are available, because regardless of the length of the suspension that's imposed on the athlete, whether that be 2 or 4 years, it's rendered futile if the changes in the athlete's body are permanent. You're met with a situation where a gene doper could return after 4 years and compete with a genetic advantage that's permanent against a traditional pharmaceutical doper who was also similarly suspended for 4 years. The second issue concerns the difficulty of detecting gene doping. Now, gene doping agents that remain localized in the muscles, as is the case of IGF-1, do not circulate in the bloodstream, which means they remain undetected using traditional methods of random blood or urine sampling. Moreover, any protein that's produced from a transfer gene is equally unlikely to be detected because they've been engineered to mirror the proteins that have been naturally produced by the body. The only method that is currently available for detecting gene doping is by way of biopsy, which requires taking a slice of the athlete's muscle at the site of the injection in order to test for injected viral particles. But because athletes must provide consent for others to collect, preserve, analyze, or use any of their biological samples under the Olympic Movement Medical Code, it is unlikely that athletes will be willingly consenting to undertaking such testing given the invasive nature of the procedure. Finally, even if there's a proper means of detecting gene doping, there's still a difficulty of distinguishing it from other more legitimate means of improving athletic performance. And here there is a fine line between gene doping and gene therapy, and gene doping and genetic mutation. Gene therapy has inevitably attracted interest amongst athletes for its ability to speed up the healing process of certain injuries, such as tissue traumas. This can be achieved by treating the injured tissue with growth factors, which are proteins that stimulate cell growth. And it not only assists with the regeneration and growth of the tissue, but also stimulates cell reproliferation. Given that gene doping is an extension of gene therapy, the method adopted, the gene that's utilized, and the outcome achieved is essentially the same. And it's therefore no surprise that distinguishing between the two will be virtually impossible. And in fact, the line of distinction may merely be purposive. If that is the case, given the severe consequences that an athlete might face if they're found guilty for gene doping, then they can simply receive receive the same result under the guise of gene therapy. In terms of genetic mutation, there will ultimately be outliers for every case, and in this context, no anti-doping authority is adequately prepared for an instance in which the athlete is born with a genetic mutation. For instance, Finnish cross-country skier and 7-time Olympic medalist Eero Mäntyranta was accused of doping because his red blood cell count was 30% higher than the average athlete, and it was only discovered later that this was due to a naturally occurring genetic mutation which produced more EPO in his body, and later doping charges were dropped against him. What then is the World Anti-Doping Agency to do? Several recommendations for reform have been made. One option is to legalise gene doping as a whole. The rationale behind this recommendation is to avoid athletes unduly exposing themselves to further risks of gene therapy in the illicit use of highly experimental technology that would in most cases be unregulated. Proponents of gene doping justify this practice by distinguishing it from traditional pharmaceutical doping. Specifically, for gene doping to take place, the genetic material is assimilated into the body, whereby the body naturally produces the desired substance. In contrast, traditional pharmaceutical doping involves the insertion of a foreign substance or hormone into the body. Some academics draw an analogy between gene doping and the use of altitude chambers. So when undergoing high altitude training, the body is forced to adapt to the lack of oxygen, which allows the body to produce more red blood cells. And while many argued that altitude chambers was contrary to the spirit of sport, the agency's decision not to ban them ultimately turns on whether the technology supports or just detracts from sport as the expression of natural talents and their virtuous expression. That is because the increase in red blood cells is naturally invoked by virtue of the low oxygen levels rather than a pharmaceutical reaction, and therefore altitude chambers weren't banned. But if genetic material cannot cause the body to go beyond what its genes will otherwise allow, as is the case for altitude chambers, this may form the basis of a justification, albeit a weak one, in support of gene doping. The issue with legalising gene doping, however, is that the fundamental spirit of sport will ultimately be compromised. It's foreseeable that the outcome of any sporting competition will largely depend on the athlete's socioeconomic status, their access to safe methods of gene editing technology, and also each government's willingness to invest time and resources into such technologies. 3 other recommendations are essentially variations of one another, which aim to accommodate the legalisation of gene doping. One suggestion is to have separate categories for all athletes based on the amount of genetic material that's present in the body. So once they've passed a certain threshold, they will be moved from natural to enhanced to super enhanced. The second recommendation is to create a separate competition altogether, such as a Bio-Olympics or a Super Olympics, where the skills of all gene dopers would be assessed against a completely new criteria. The question there is, who is going to spectate the ordinary Olympics then? And the final suggestion is to place a handicap on enhanced athletes in a way that would ensure a level playing field. It may come in the form of an extra number of seconds at the start of a race, or an extra number of kilograms for weightlifters. But the difficulty with this, again, is how each athlete's genetic advantage is to be quantified in order to provide the athlete with an appropriate handicap. On the other hand, those who have fought strenuously against gene doping opine that while athletes should still face some sort of punishment for gene doping, liability should also be imputed on those who possess or exercise some degree of control. And the rationale behind this recommendation is that in reality, the motivation to engage in gene doping isn't likely to be purely self-driven. And there will inevitably be some pressure from coaches, sponsors, or even governments. This has seemingly already been incorporated into the code though. Specifically under Article 2.9, anyone found to be complicit with the involvement of anti-doping violation will be ineligible for 2 to 4 years, depending on the seriousness of the violation. And the problem with this recommendation also fails to overcome the obstacle in being able to detect gene doping in the first place. To summarise, gene doping is ineffective under the World Anti-Doping Code. Thank you.
a very good presentation, and I have a few basic questions. One will be, I wasn't particularly clear, what's your position? Should we prohibit this or should we regulate this?
So I think, in my opinion, we should prohibit it. I don't think legalising gene doping works for the reasons I mentioned earlier. It's going to be dependent on everyone's socioeconomic status. There's currently research into more or less invasive ways to detect gene doping. So I think it's a matter of whether or not whether or not technology will be able to keep up with prohibiting gene doping by using correct and appropriate methods of detecting it that don't require a biopsy.
What about those situations like the Finnish skier, where you've naturally got what other people would have, what other people would need to acquire through gene doping? So isn't there an argument to say, let's allow it to perhaps level the playing field?
There is certainly the argument that if one person is unusually gifted in sports, then everyone else should be able to receive those gifts by engaging in gene doping. But I also think that the spirit of sport and the meaning of sport is the natural expression of an athlete's talents. And if someone is born with more EPO in his body, then it doesn't necessarily mean that everyone else should be given that kind of genetic advantage.
So is that just like allowing a freakishly tall person to play basketball?
Yes, which is the case that happens. Not every basketball player is the same height. And I think it's a little bit different in terms of team sports as well, because there's also success is also dependent on tactics and whether or not that team works well together. But yeah, ultimately, it doesn't mean that you're going to have a basketball player or a basketball team of players of the same height compete with another team with players of the same height as well.
Look, on that note, by way of comment, I know that in the bobsled there are weight limitations, because what happened over time was that some teams just put more and more fat people in the end. So presumably countries like America would have a great advantage in this. So there are some limitations. The other thing I'd ask, by way of comment, is your concern more about the coaches rather than the players? Because one would think that in a lot of instances gene therapy could be offered to the players or put to them in a way that they can't refuse. So at a superficial level, it's a question of advantage or disadvantage with competitors, but at a deeper level, we're talking about exploitation. And if we remember back in history, a lot of athletes from the former East Germany essentially said, we weren't given a choice, we were just given steroids, and that was that. Do you think the same thing will happen with gene therapy?
I think the same would happen, but in terms only of gene doping. So that's basically what the code is taking into account in terms of Article 2.99. So a coach would therefore be complicit in helping someone engage in gene doping. I do think, however, that the sanction that those kinds of coaches are facing, which is ineligibility for 2 to 4 years, is not harsh enough. Because ultimately, as you say, the pressure that an athlete receives might be too overwhelming, and most of the time it might not even just be the athlete who is unwilling to undergo gene therapy. Gene therapy, however, is very different from gene doping. There are people who tear their muscles and do have to take gene therapy in order to quicken up that healing process. And in terms of the bobsled weigh-in, I think that's where the measurable handicap recommendation comes into play. So having an actual level playing field. But again, I don't know how a genetic advantage is going to be quantified or measured.
I at this stage I might start to just provide some feedback for you based on my observations. I really enjoyed the way that you grabbed the audience's attention and engaged us from the outset. You said in your opening words, in the world of sports where stakes are high, and for me that really just tossed me into the relevance of the presentation from the very outset, so I thought that was fantastic. Wonderful job in the context of structuring things and taking us on the journey, signposting for us where we were going next. So for example, you actually said the words, my central thesis neatly stated, is, and filled that in for us. And then you said, so what is it? You know, and then you took us on that journey in a way that was reminiscent, I think, of a good doctor explaining for a patient something that was very complex, and the subject matter is really complex and difficult for a generalist to sort of, you know, come to terms with, particularly in 15 minutes. But I thought you did a beautiful job of sort of articulating that hard subject matter by signposting and sort of using appropriate, I guess, pitch and tone and pause and so forth. Having said that, the word pause, there was a point at which I thought perhaps more opportunity, you know, might have been sort of, you know, grabbed to really utilise pausing more efficiently. I think the time that I'm thinking of was we were dealing with some relatively serious stuff. You were talking about the heart failure in mice, and you were talking about the damaging of nerves and so forth, and then beyond that, talking about the human leukemia diagnosis and so forth. And I really felt that that was your opportunity to take a second to really sort of just even very subtly reflect on how serious this is, this subject matter, and give the audience an opportunity to be really hungry for the next phase of the talk. So that's just something that I noticed. I thought that it was all very interesting. I mean, I was fascinated by your overview of the biopsy, you know, and the complexity around that possibility. I guess for me, ultimately, I felt that the conclusion was just slightly sudden and slightly abbreviated. And I wondered if that was perhaps because your timing had sort of been mucked up in some way that was seamless on one level, because I'm not sure how it was mucked up, but I suspect it was, because it was quite a sudden end to what was a very interesting talk otherwise. Thank you.
Look, I'd endorse what Skye said about the way you sort of opened and drew in the concepts. When Skye said a generalist audience, I think that's kind. I think most lawyers, I know I'm one, we end up in law and social sciences because we don't understand science. Yeah. It happens in about year 11 in school. All of a sudden you realise you can't understand the maths anymore, and you don't want to sort of cut up dead animals. And so, you know, to a large extent, science is beyond us. And I thought the way you crystallised and clarified the key concepts was really effective. And because that's one of the gifts of legal presentation. It's to essentially make us feel as if we understand concepts. We can't understand, but we can understand enough for a legal analysis that involves scientific issues. So I think that was particularly effective, and I think allied to that, the use of PowerPoints was really effective, because it was an occasion where to just sort of lay out and guide the key points was very good. I think, you know, another example is the ones you've got up there. The material you reproduced from codes like that, it was core stuff that was very effective. So I think, you know, overall that communication of different concepts was effective. I also liked the way you drew together the different definitional things to essentially say, this is what this means, this is how that works. So I think that there was a very good connection between the general and the... Maybe I'm back. There was a great connection between general concepts and specific analysis, and I think that moved effectively towards a good argument. I didn't find the same level of abruptness towards the end that Skye did. I think one of the things that could have enhanced it is if you could have been more open about the fact that maybe this isn't really capable of clear regulation, because I think one of the things you could have acknowledged more clearly is that, drifting away again, that we're just at the dawn of this, and what we're trying to essentially do, I think, is develop an interim regulatory structure for something that's going to continually evolve.
Thank you.
Thank you.